Composite pattern. Composite pattern lets you compose objects into a tree structure while treating individual objects and composition of those objects uniformly. So, tree node will have basically leaf node and branch node, right? And you are going to treat both individual object, meaning the leaf node and the branch node, uniformly. When to use it? Use it when there is a part-whole hierarchy of objects, like employee structure in a company or file system, and client needs to deal with objects uniformly regardless of the fact that object might be a leaf or a branch. So examples are file system or the employee hierarchy in a company. So you have president, have directors, and directors have managers, managers have individual contributors, and things like that. Okay, so component interface. So this is an abstraction for leaf and composites. Okay, so composite is a branch node and leaf is the end node. Okay, and both of composite, meaning branch node, and the leaf, they all have to implement composite interface. Okay. So then we have a leaf node and leaf and the composite. Composite is a branch, leaf is the end node. Leaves are objects that have no children, and composite has children. Okay, and then client should be able to actually access the tree structure. Okay, so let's take a look at the examples. Composite. Okay, so here composite employee structure. So here we have employee interface. This is a common interface that both the employee and the manager should implement. So employee has name and department and salary. Okay, and at the end it also has an abstract method called the print tree. Okay, so this is the abstraction that will be implemented by manager and individual contributor and director and president. Okay, so let's take a look at the individual contributor. So individual contributor implement basically it will have name and department and salary injected, and then print tree, it will just display the name and department that employee belongs to. As far as the manager is concerned, because manager has the children, so it will go through, in fact, all the employee that manager manages. So it is in fact a full loop. Okay, and so it should have list of employees, right? So this is a branch node. So branch node should have a list of other nodes, and that other nodes could be either end node or it could be another branch node. Okay, so it has the set of list of employee in this case, and then we have add, remove, and get subordinates, and then we have a print tree, and print tree is basically get all subordinates. Okay, and then each of those will be the type of employee, and we basically call print tree. Okay, all right, so that is a manager. Now if you take a look at the client code, so we have to construct the tree structure. Okay, so as an example here, so we have created a manager. So manager, we have created two managers. In fact, actually this is role, the manager and the another manager, and then we have a two individual contributor, and we actually have 4 individual contributors, and then we are adding this manager to the CEO. So head sales manager will be added to CEO manager, and the head marketing will be added to CEO as well. And the sales executive one, this is individual contributor being added to head sales manager. And so head sales has a 2 sales executive individual contributor, and head marketing has a clock 1 and clock 2. And then we are going to call print tree from the CEO, right, the top of the tree. So in this case, if I'm going to run the application, Yeah, so John is the CEO, and John has Robert, head sales, and Michael, head marketing, and Robert has Richard and Rob, and Michael has Laura and Bob. Okay, and the general is basically we have a component. This is the interface. Okay, and there's a print tree, and composite. This is a branch node. It has a list of that component, and the print tree will actually go through each subordinate child components. Okay, child components is basically this guy, and then leaf node. Leaf node has just print tree. It just display the name of it. Okay. And client, you can certainly create a tree structure. We create a 4-leaf node, and then we create a 3-branch node, composite node. Then we construct a tree, and then we basically print a tree. Okay, so in this case, if I run the code, yeah, so component 1, composite 1, yeah, so root node has a composite 1, composite 2, and composite 3. So composite 2 has a leaf 1, leaf 2, and leaf 3, and composite 3 will have just a leaf 4. Okay, okay, so composite pattern is tree structure pattern. Okay, so that's pretty straightforward. The homework. So homework is file system. You want to simulate a file system using composite pattern. So here, let's take a look at the homework description. Okay, so what we want to do is you want to simulate a file directory structure using composite pattern. The file system has root directory, which has 2 subdirectories, one of which has 2 files. Okay, so you are going to uncomment the client code, create a node abstract class. So this is that represent the abstraction for all node. Okay, and then we are going to create a file class that is a leaf, and then you create the directory class. So the end result we'd like to see is we have a directory, and then we have a root child 1 directory name, and root child 2 as a second directory that belongs to the root, and root child 1 has file 1 and file 2. Okay, so node is provided. So basically it does have a print tree, and it just maintains name. Okay, okay, so that is the homework, and that is in fact